Hi there. So let's discuss about what is the real zero, what is the real zero of some function, and how does their multiplicity works. We'll discuss this real zero and multiplicity at this point. To do it, let me write some just normal one, some factoring maths. Say x squared minus x minus 6 equals to 0. Suppose this is some kind of normal, just simple, some quadratic equation, and we are interested to solve it. So we do the factoring thing in different way. So this is one way to do it. So we can write x plus 3x, then minus, not plus, let's write here minus because leading is minus, so it write twice x minus 6 equals to 0. And how this factor comes, this comes from 6, because we can just from 6 we get 3 and 2, then from 3 minus 2 we get this minus 1, and we have to give here negative, we have to give here positive, and positive negative also matching with this minus 6 if you are interested. That is just simply just algebra. So if we take common x, x from this first two term, this one and this one, then it becomes x minus 3. Then from this one, if we take 2 common, then it becomes x minus 3 again equals to 0. X minus 3 it becomes then x plus 2 equals to 0. So then from this we can write, from the zero multiplicity, from the zero product rule, we can write x minus 3 equals to 0. Then we can write x equals to 3. Then we write x plus 2 equals to 0. Then we have x equals to minus 2. So we found x equals to minus 2 and x equals to 3 for this equation, for this quadratic equation. What does this x equals to 3 and x equals to minus 2 means? It means if we plug in this minus 3 here for x, then if we just square it, then right here 3, then right here as it is, then if we do the calculation, then our answer will come 0. That means if we put x equals to 3 in this question, then answer comes 0. If we put minus 2 also, then it comes 0. This is how we validate the given question. Now we can write the same thing in terms of function. So if x equals to, then it will be x squared minus x minus 6. And then in the same way we can factor it also, then it will become x minus 3 into x plus 2. So basically what we are getting here is the factor of this given function, of this function. And you see this 3 and this 3, and basically the same thing. This is actually the same thing. So both of these two things is just simply different way of writing, and how this thing, both of this thing is related, and what this x equals to 3, x equals to minus 2 signifies in this situation. That's our main thing. And if we understand that, basically we will understand the real zeros and multiplicity. Multiplicity is actually in another, I will just add it in a while. So this x equals to 3 means if we put this in the given function here, then the function becomes 0. This x equals to 3. And this x equals to minus 2 also, if we put here, then our function becomes 0. You can put any other number, then it will not be 0. It will be something else, but the function will not be 0. That is why this x equals to 3 and x equals to 2 minus 2 is called the real zero of the function. So x equals to 3 and x equals to minus 2 are real zeros of the function. These are the real zeros of the function. And when this x equals to 3 and x equals to minus 2, these are the real zeros of the function. Suppose if it is given, then what other decision? We can make some other decisions about this also. Then suppose one decision. Let's say suppose x equals to 3 and x equals to minus 2 is given, and they are asking you what does it mean, or what you understand from this. Then you can say, if x equals to 3 is a real zero of some function, that means at x equals to 3, at x equals to 3, the function becomes 0. The value of the function is 0. the value is 0, then you can say if x equals to 3 is the real 0, then you can say then x minus 3 is a factor of the function. And then also you can say at x equals to 3 we have the x-intercepts of the function. So 3 additional decision actually we can make from this real 0 if it is given. And the same thing actually we can say about this x equals to minus 2 also. We can say at x equals to minus 2 we have the case where the function becomes 0. Then we can say x plus 2, opposite of this, x plus 2 is the factor of the given function. Then we can say at x equals to minus 2 there is an intercept of this graph. So basically these are the real 0. This is what real zeros means. Now what is the multiplicity? Multiplicity is basically the power of this factor. So the power of this factor is 1 and the power of this factor is 1. So the multiplicity for this quantity is 1, multiplicity for this quantity is 1. Let me write one example where multiplicity is different. Let's say if x equals to, suppose some new function, something like x minus 1, then x plus 2 whole square. This is some new function. In this case, multiplicity is 1, in this case multiplicity is 2. And real 0, for this question real 0 will be x equals to 1, and for this term it will be x equals to minus 2. So for this one real 0 is x equals to 1, and this one's multiplicity is 1, and in this case the same multiplicity is, this is 2, this 2 is the multiplicity. And basically this multiplicity actually defines another interesting thing in the graph. If there is a condition, if this multiplicity is 1 or any odd number, let me write it here. If the multiplicity is odd number, then the graph will cross at that x-intercept. That means, look at this, when x equal to 1, that means at x equals to 1 there is the intercept for the function. Actually I will draw the graph in some other video for the given function, so there I will actually show it. So at that point actually the graph will cross at this x equal to 1. The graph will cross means, okay, let me show you. Then let me show some random graph. Suppose this is a graph. This is not the graph of this function, this is some random graph. And let's say this is not, this didn't stop here, so this is, say this, for example, this is going forever this direction, this is going forever this direction. So you see at this point the graph actually crossed the x-axis. At this point the graph actually crossed the x-axis. Here also the graph actually crossed the x-axis, but at this point the graph only touched it. Can you see this? At this point, okay, let me show it. Okay, all right. So at this point the graph actually crossed it. This graph crossed it, and then this graph touched. Just here only touched. So basically we can see two kind of situation: graph can cross or graph can touch. When the graph will cross? If their multiplicity is odd. If the multiplicity is odd. For example, at this point, these graphs, this is some different graphs. At this point, these graphs multiplicity definitely was odd. That's why it crossed. That at this point it was odd. Here also odd, but here it was even. Even means like this, power 2. If the power is 2, then the multiplicity is even. If the multiplicity is even, then the graph will touch. The x-axis. At that graph will touch the x-axis. So cross what it will cross? X-axis. Yeah, x-axis. It will cross the x-axis. It will touch the x-axis. We have to look at the multiplicity. Multiplicity means the power of the factor. Power of the factor is the multiplicity. So for x equals to 1, multiplicity is 1. for x equals to minus 2, or at x equals to minus 2, multiplicity is 2. This way also you can say it. So this is how this thing works. Okay, let me show you this if you want. So that's our formula or rules for multiplicity and as it works. So thank you all, thanks for watching, bye bye, hope it works, bye.